Let's consider a parallel program executing on a parallel system. The ISO efficiency metric of scalability is a measure of ability to increase the performance as the number of processes increases. In simpler words, what we are trying to achieve is that we increase the number of processes. Also, we are trying to maintain the efficiency of the parallel program as well. So remember the equation for speed up. Speed up is given as psi n comma p is less than or equal to sigma of n plus phi of n divided by sigma of n plus phi of n divided by p plus kappa of n comma p. Now we are going to multiply this term, both the numerator and denominator using p. Now we have p sigma of n plus phi of n, the whole divided by p sigma of n plus phi of n plus p kappa of n comma p. Now we are going to rewrite this equation as this. Here what we have done is this p sigma of n is actually decomposed into two terms, sigma of n and p minus 1 sigma of n. We can write phi of x as x plus 4x. That is what we have done here. We have decomposed the p sigma of n into sigma of n plus p minus 1 sigma of n. Here we are defining a new term T0 of n comma p to be the total amount of time spent by all processes doing the work which is not done by the sequential algorithm. So one component of this time will be p minus 1 processes spending the time on sequential code. That means p minus 1 into sigma of n. The other component will be the time spent of all pre-processes for the communication, for the inter-process communication. So T0 n comma p is equal to p minus 1 sigma of n plus p into kappa of n comma p. So I have rewritten the equation from the previous slide here, where psi of n comma p is written in terms of sigma of n and p minus 1 sigma of n. Now this term is replaced by T0 n comma p. Now we have p into sigma of n plus phi of n divided by sigma of n plus phi of n plus T0 np. Now hope you remember the efficiency equation, which is given as sequential execution time divided by the processors used into parallel execution time. So what is efficiency? Efficiency is given as epsilon n comma p, which is less than n sigma of n plus phi of n divided by sigma of n plus phi of n plus T0 n comma p, where we have rewritten the equation of efficiency with T0 n comma p. I will explain again. This is the equation for speed up. Now efficiency is given as speed up divided by this number of processors used. So what we are doing is we are going to divide this entire term by p, which gives us the new equation sigma of n plus phi of n divided by sigma of n plus phi of n plus t naught n comma p. Now I am going to divide this term with sigma of n plus phi of n. If I divide the numerator with this term, we get 1. Again, we divide this composite term by sigma of n plus phi of n, we get 1 again. Now T naught n comma p divided by sigma of n plus phi of n. So epsilon is rewritten as this equation. Now we are going for the further derivation. For the sake of simplicity, we are going to define A is equal to epsilon of n comma p. B is equal to T naught n comma p. And C is equal to T of n comma 1. So what is written here? That is A is less than or equal to 1 divided by 1 plus B by C, which is equal to 1 plus B by C. The whole thing into A is less than or equal to 1. Again, A plus AB by C is less than or equal to 1, which is equal to AB by C is less than or equal to 1 minus A. Now, which is equal to, again, AB divided by 1 minus A is less than or equal to C. Now, what is A? A is equal to epsilon of n comma P, which is divided by 1 minus A. What is 1 minus epsilon of n comma P into what is B? B is T naught of n comma P is less than or equal to T of n comma 1. Now you can see that this is what we have arrived. So if epsilon of n comma p divided by 1 minus epsilon of n comma p as a constant, if we denote that term as a constant c, it says that the time taken for sequential execution will be greater than the constant multiplied by t naught n comma p. This is the isoefficiency relation of scalability. So the isoefficiency relation is stated as, given the efficiency of a parallel system as epsilon n comma p, and the term c is defined as epsilon n comma p divided by 1 minus epsilon of n comma p, and also the term t naught of n comma p represents the time taken for p minus 1 processor to run the sigma of n plus p into kappa of n comma p. In order to maintain the same level of efficiency, as we increase the number of processors, n must be increased, so that we say that the total time taken for the sequential execution time will always be greater than the constant into T naught n comma p. So this is the isoefficiency relation of scalability, and here is the end of fourth performance analysis metric. We will be seeing few problems in further sessions. Thank you.